Hey there everyone, welcome to 5.1 part 2, graphing polynomial functions. The first time I did this video it came out a bit long, and so what I'm doing to save time is having everything written down, and I'm just going to go through how I explain it. Okay, so there's some calculator stuff in this video, and I've made notes of how to do it, but if you want to see more detailed walkthrough of how to do it in the calculator, click the link in my description, and there's a video of me doing it on the calculator. I can't merge the two videos because I don't have any editing software. But yeah, okay, so let's get started. I'm going to start by graphing this function. Okay, so I need some points to graph and to give me, the basic shape of the graph. So I have the x values given to you. All you have to do is plug it in and press Control T. So get these points, alright, write them down, and then just plot them on the graph here. And so I plotted them, they're all the black dots. Alright. So what I did next was I just filled out this part, the degree. It's 3, and the leading coefficient's -1. I know the degree is 3 because that's the highest power, and -1 is in front of the x to the third. Okay? And so the degree is odd and the leading coefficient's negative, so you could refer to part 1, that chart on the back of 5.1 part 1, and it would tell you this. But looking at the graph that I've already drawn, you can tell that as the graph goes up, as f of x goes to positive infinity, x is going to negative infinity. And then as f of x goes down, so as f of x goes to negative infinity, x is going to the right, so x is going to positive infinity. So since we read things from left to right, the x ones are always going to start negative infinity to positive infinity, and then the f of x ones are the ones that can change, alright, depending on the behavior of the graph. The next thing I did was find the local max and the local min. So these are the coordinates of my local max and local min. With the graph plugged into the graph, with the function plugged into the graph, I did menu, analyze, and then there's a min option. There's also a max option. Okay, so do the correct one for the correct question, and then I just plotted them, to the best of my ability here and here. So anytime there's a little bit of a dip, it'll be a local minimum. Anytime there's a little bit of a peak, it's called a local maximum. It's not called a vertex or anything like that, because a vertex is the absolutely lowest point or absolutely highest point of a graph. And this is a graph that's just running through those points, okay? Okay, so what I went through next was finding these increasing and decreasing intervals, okay? So let's look at the graph as to where it's increasing and where it's decreasing. So in red, I drew the lines, reading it from left to right, it's going down, then up, then down again, okay? So the first blank is for where is it increasing. So it's increasing basically between the local min and the local max, okay? So when you do these interval problems, you just need to look at the x-coordinates of the numbers. So let's go back and let's look at that. So my local min was here, that x-coordinate, and then this is the x-coordinate of my local max. So it's going to be increasing between those 2 points. So you see how I wrote those numbers again, the smaller one to the bigger one. And then the important distinction here is that they are in brackets, because remember, it's interval notation. So brackets indicate that you pass through those points, and parentheses indicate that you did not pass through those points. Like maybe you got close to it, but you didn't ultimately touch those. So if you're looking ahead, you see that I have a parenthesis around infinity. You're always going to have parentheses around the infinity symbols. So how did I get that it's decreasing from negative infinity to negative 0.721 and from 1.39 to positive infinity? Well, what's happening is it's coming from the left side. So it's not coming from the top or the bottom, it's coming from the left because we're reading this from left to right. So everywhere to the left of the local minimum is where it is decreasing, okay? Because, yeah, it's coming from the top and it's coming from the left. So it's moving leftward towards the local minimum. So that's negative infinity, all right? Because it's just coming from wherever it's coming from, negative infinity. You can't really put a point to it. So it's coming from negative infinity, and then it's turning at the local minimum. So that's why it's in a bracket right there. Okay? And then it goes up, and then it turns again at the local max at 1.39. And then it's going down, but it's also moving towards the right, so towards positive infinity. Forever. So don't confuse it and write negative infinity because you see it's going down. And remember, it's going down and to the right, and all we care about is the left or right for this stuff. For all these answers, these interval answers, just look at the x-coordinates, okay? So let's talk about where it's above 0 on the graph. So if it says f of x, maybe it helps to make a note that it's the same thing as y. Where's y above 0? It's just, it's just notation. So anyway, go to menu, analyze, and do the zeros to calculate the exact numbers as to where it is hitting the x-axis. Okay, so when I did that, I saw that it hit at negative 1.73, at 1, and at positive 1.73. Okay, so the intervals at which it is greater than 0 is from negative infinity to negative 1.73, because here's 1.73, and then up and then to the left. Like I said, that's the important direction. To the left of it is above, it's going to be above the x-axis. Alright, so that's why it's greater than 0 right there. And then in between these 2 points, it's clearly above 0, so I put those two in a bracket. Alright, and then where is it below 0? It's below 0 in between these 2 points, negative 1.73 and 1. And then I said 1.73 to positive infinity, because again, it's going down, but it's also going down and to the right. So that's where I got the positive infinity there. And so when you answer these questions, just keep reading the graph from left to right, and put the leftmost answer first. Okay. The last thing to go over is evaluate the function when x equals 3 to show your work. Every time you see an x, put a x equals negative 3. Put a negative 3. And make sure you use parentheses, especially when you use negative numbers, so that way you don't make a mistake. So you could type all this into the calculator. You could also go back and press Control T and scroll until x equals negative 3, and then you'd see it equals 24. But you will need to show your work, so this is how you show your work, okay? So if you're watching this and you have a calculator with you, before I scroll any further, why don't you do this one on your own, okay? So pause the video real quick and go through it and see how you did. Okay, so plugging in this into Control T got me that, and I plotted them with the black dots. The degree was 4, that's an even number, and the leading coefficient was 1, which is a positive number because there's nothing in front of x to the 4th. So looking at that chart, it would tell you this answer, but also looking at the left side of the graph, it is going up, so I said positive infinity for f of x, negative infinity for x. Again, I said this will be negative, that'll be positive no matter what. And then on the right hand side, it's going up and to the right, so positive infinity and positive infinity. I did that menu 6.2, I believe, or menu 6.3 for max, maybe. And it's at 0.4 right there. And then I did menu 6.2, and you had 2 different local mins. Like I said, every time there's like a little peak or valley, you have a local min or max. And then it's increasing between this local min and that local max. Just use the x-coordinates. So there they are. And then it's also increasing from this local min and going up and to the right forever. So 1.84 to infinity. Alright? Where is it decreasing? It's decreasing coming from the left, so coming from negative infinity to that local minimum of negative 1.09. And then it's also decreasing between this local max and this local min. So this x-coordinate is 0, this x-coordinate's 1.84. Where is it above 0? Well, I did that menu analyze zeros. So I think that's menu 6.1 on the Inspire. The zeros are 1 and 2.838. So everywhere to the left of the 1 is above 0. So I said negative infinity to 1. And everywhere to the right of 2.838 is also above 0. So I said 2.838 to positive infinity. And then in between these 2 points, it's below 0. So that's where I did that. And then I just plugged in 4, and I got 132. Okay? Let's move on to the back side.